Hello everybody, this is Vipul Purohit and I welcome you all to my YouTube channel. My dear friends, as you can see over here, the title of this particular video is about second order reaction. Yes, my dear friends. Second order reaction is that reaction where the rate of the reaction is proportional to the second power of the concentration of the reactants which are actually involved in the reaction. Okay, this is a second order reaction. So let us go into the integrated rate law expression for the second order reaction. So here we start with, let us consider a reaction whereby I have 2 moles of A getting converted into, say, B. So this is one possibility. Either we have 2 atoms of the atoms of the same element, or we can have 2 atoms of different elements. So I can also write it down as another way, and that is A plus B gives me C. So we say that in this case the reaction is in second order with respect to A. Here I will say the reaction is first order with respect to A and the first order with respect to B, and therefore the overall order of the reaction is 2. Alright? Right. We go into the next part now. Let us consider A as the initial concentration of the reactants. Okay, initial concentration of the reactants. Let X be the concentration of the reactants reacted in a particular time, and that is, say, T. स्मॉल t का मतलब होता है टाइम, कैपिटल T है तो टेम्परेचर. अभी A इनिशियल कॉन्सेंट्रेशन है, उसमें से X अमाउंट रिएक्ट हुआ तो बचा कितना? यस, इट्स A minus X. सो A minus of X is the concentration of the reactant remaining after the time T. Okay, remaining after the time T. So according to the rate law expression, what we are going to say is the rate of the reaction is proportional to the second power of the concentration of the reactants which is remaining at that particular time. So therefore, what we have is the rate of a reaction is proportional to the second power of the concentration. So therefore, I am going to write it down as A minus of X the whole square. Now that rate is given as the rate of change of the reactant with respect to time. So I write it down as dx by dt is proportional to A minus of X the whole square because it is a second order reaction. अब मैं proportionality sign निकाल देता हूँ. So what I have is dx by dt is equal to k into A minus of X the whole square, जहाँ पर k is the rate constant. Okay, अभी क्या करेंगे? A minus of X the whole square will be on the left hand side, dt will take it on the right hand side. So we get dx upon A minus of X the whole square is equal to k dt. Alright, now we'll do the integration of this. So integration of dx, A minus of X the whole square, k is a constant, so it's outside the integral sign, dt. So we have is solution of dx upon A minus of X the whole square gives you 1 upon A minus of X, that is equal to kt plus k dash. Now what is k dash is? It is the constant of integration. So I write it down as IC, integration constant. If I want to find out the value of k dash, then I assume that the reaction has not started and t is equal to 0. अब जब रिएक्शन शुरू ही नहीं हुआ है तो रिएक्टेंट प्रोडक्ट में कन्वर्ट होगा ही नहीं. तो इस तरीके से अगर आप देख रहे हो यहाँ पे x, कॉन्सेंट्रेशन ऑफ द रिएक्टेंट रिएक्टेड इन टाइम t, तो यहाँ पे कोई रिएक्टेंट रिएक्ट ही नहीं हुआ है, यानी इसका मतलब x इज इक्वल टू 0. अब ये एक्सप्रेशन इसमें सब्स्टिट्यूट करेंगे. सो व्हाट वी हैव इज 1 अपॉन A माइनस ऑफ X इज इक्वल टू के टी प्लस के डैश। इस इक्वेशन में अगर मैं सॉल्व करना चाहता हूँ तो अब ये हो जाएगा 1 अपन ए, क्योंकि ए माइनस ऑफ 0 दैट इज इक्वल टू के टी है तो के इंटू 0 इज 0 दैट इज इक्वल टू के डैश। ओके, सो 1 अपन ए इज इक्वल टू के डैश। अब ये इक्वेशन इसमें अभी वापस आप शुरू कीजिएगा। सो व्हाट वी गेट इज 1 अपॉन ए माइनस ऑफ एक्स इज इक्वल टू के टी प्लस 1 upon a. This is what we get. Okay, 1 upon a minus x is equal to kt plus 1 upon a. So kt will be equal to 1 upon a minus of x minus 1 upon a. So that is equal to a minus of a. अब ये माइनस माइनस है तो ये प्लस हो जाएगा, सो प्लस x इंटू a माइनस ऑफ x। अब ये a और ये कैंसिल हो जाएगा, सो क्या बचेगा अभी, के टी इज इक्वल टू ये x बचेगा अपॉन a इंटू ए माइनस ऑफ x। सो वी हैव k इज इक्वल टू 1 बाई t इंटू a इंटू x अपॉन a माइनस ऑफ x। ओके, t में राइट हैंड साइड में लेके आ रहा हूं तो आई विल ब्रिंग इट ओवर हियर अलॉन्ग विथ a। सो 1 अपॉन a t x a minus of x. This, my dear friends, is the integrated rate law expression for the second order reaction. So I hope you have understood this very well.